Hi guys, welcome to my channel. It's a lovely day in Zimbabwe. We are under lockdown, and I just thought, wow, we could use this time to just go through R and work with dates and times in R. Okay, so let's begin. So there are different conventions that are used in different places for dates. For example, you see that in New Zealand, they prefer to start with the day, the month, and the year. And in the US, they prefer to start with the month, the year, and the date. In Zimbabwe, we prefer to start with the day, month, year, right? So, given that, we find that there was need for people to have a global agreement on the numerical standard, on the global standard numerical data format. So this was done in 1988, and people agreed that to have the ISO 86011, which starts with year, month, and day values ordered from the largest to the smallest. But just to give a bit of context, we see that before that, people were using different dates. Some were even went further to use Roman numerals, as you are going to see there. Then some used brackets. It was very, very interesting. As you can see from the display where I'm hovering my mouse there, you can see the different formats that were used. Right. So now after the ISO, people agreed that you can use a date without a space, which means that you could have a date maybe like this, like 2020, right? Like 2020 02 27, or you could use 2020 dash 02 27. So whichever case you prefer is fine, as long as maybe you can stick to it, that's okay. But the machine can doesn't have any problems reading such values. Right. So let's proceed. Right. So dates in R. So when we have a date, you need to tell the machine that this is a date. For instance, let's say you have a date and you don't tell the machine that is a date. This is what's likely to happen. It's you can see in my console below that the date is being read as 1974. Right? I'm running this code. I want you to look what happens here at my error console. You can see that it's saying 1974, which is the number of time that is elapsed since the date 1 January 1970, right? But if you're using base R, you can then say as date. Then you see that R has read the date. Wow, that is 2003-0203. But another trick is that the fact that there is a string there, that doesn't mean anything. It doesn't really tell us that it's a date, right? For instance, I'm going to put a string here, which I'm going to run. You can see that is similar to the code that's running above. But when I inspect the structure of the data, it's telling me that CHR, which means that it's a character value, which means that you cannot do addition, subtraction, and get values, multiplication, among other things. So if we now use this date and inspect, you can see there in my console that the format has been read correctly as a date. Right. So for working with dates and times in R, there's a package called read R and end time which you can use. Then you look at why do we need to use date. Dates act like numbers, which means that you can perform subtraction, addition, multiplication, which can help us to look at a time in the future. Let's say we can do multiplication, addition. You can actually have a date in the future or in the past. Then multiplication, you can calculate. Subtraction, you can calculate things like time intervals, a period, etc. Right. So we can also do comparisons, logical comparisons. If you can see there, I've got as date 2003, and which I'm going to compare there. If you can see where my mouse is. So if I run this code, you can see it's true that 2003 is greater than 2002. Then I can do addition, like I was saying. You can see that the date was 26, now we have 27, right? Then you can also do subtraction, and you get the time difference is 365 days, right? Which is good. Then you can also do data visualization, like you can plot. So here I've got a vector of dates, which is 2003, 20 February, March, and April, and I'm going to plot it. So I'm using the function base arrow plot x, which is this vector which I've created. I created the vector, which is now there. If I call this vector, let's call my x, I can say print, I can say print, right? So if I print my x, or better still, I can just print my x, because my keyboard is faulty. If I print my x there, you can see this is the vector that I have created of dates, and now I'm saying print the vector of x, the dates and the x-axis. So what I can do here to show you that maybe okay, so let me just fix this issue of the keyboard so that we can work fast. Right, just give me a second. I'm installing the keyboard right away. Okay, so I've got the keyboard. So if I could say now is equals to, then I could say y, my y, or what's going on, y is equals to this, right? So if we run that, it's showing me that the figure margin is too large. Okay, so let's remove that and just say, let's just stick to the basics. You're going to see a plot there which is showing us the date in the axis and our y, right? So we can also use the library ggplot, which I've loaded. Then in the x-axis I'm going to put the vector, and in the y-axis I'm going to put y is equals to 3, which is what I was trying to do. So ggplot, as you're going to see, it creates beautiful visualizations. Is the one that you can see below there. We have got our data points showing on the screen there, 1 to 3, and the dates. So what about times? Okay, so you can see there that in terms of time, we can also go further and talk about the hours, minutes, and seconds. And if in terms of hours, you're talking about 24 hours. Then in terms of minutes, you're talking from 00 to 59. Then seconds, we can 0 to 60. Then the separator, you can use the separator or nothing, right? Then let's discuss further about date times in R, right? So there's this item called a POSIX. So then we've got POSIX LT, which lists with named components. Then POSIX 60 seconds since 1970. If you remember, I discussed about it earlier on. So the POSIX is very important when let's say we have a vector or a data frame, as you're going to see the data frame. So if you run it and store it in a POSIX, once it's stored in that, it means you can do a subtraction, addition, multiplication, which is basically data manipulation, right? So I've stored this vector. This is just a date, and when I now call str, is telling me that it's a POSIX format 1970-001, and it's giving me all those things. So this is very cool when you want to work with time zones, like the different time zones that are there. So we can proceed. If you have a date, so what you just need to do is to store it as a POSIX city, then you can start working on it. As you can see there, you can also specify the time zone using the function tz is equals to, which is provided by the same function, right? So we can see the data has been stored there as UTC. So this have behave nicely too. Once epoxy object datetime can be compared, subtracted, and plotted. So that's it about text. Then for dates we've got a library called Lubridate, which makes working with dates and times in R easy. It's designed for humans, not computers. It plays nicely with other device packages. It it's constant behavior regardless of the underlying object. Then the other thing is that it's also very fast. So I'm going to import the library Lubridate. Once you've got the library is ready, the other things that you can do is that you can now start to play with the dates. For instance, if I've got a date that's stored, I just need to tell that is stored as year, month, day is in that case. And if it's not the case, you can specify that it's day, month, and year. And you see that in my console there nothing has changed. Then there we also have got maybe something that's worth mentioning is the friends um, the friends of this package, right? Of Lubridate of YMD is DMY, then YMD. Then we have got others as well, which are there are plenty that you can work with. I'm just trying to look for some of the popular ones. I just hope, yeah, I don't know, should take me very less time. Just give me a second. I want to show you. Yeah, so you can also have something like this that I'm just going to put as an illustration, that the D is a numeric day of the month, right? So you're saying this is a um, numeric day of the month, right? Then we also have got the M, which denotes the month of the year. Then we also have got the year, Y, which means the year. So these are just notes. I'm just trying to explain how this whole thing come together, right? So we are saying Y means the year with century, right? Then we also have got things like this, the capital letter Y, which means year without century, year without century. Then you can also have H, capital letter H, which means hours, 24 hours. Then M, minutes. Then we also have A. We also have A, which means abbreviated weekday. Then we also have capital letter A, which means full weekday. Then you have capital letter B, which means full month name. And I, which means hours, 12-hour notation, 12-hour. Then P, small letter P. We have small letter P, which means AM or PM. So all these things they are available in the Lubridate package. I'm going to post the notes on https // um, um, arastatzim.edu blogs.org. All right. So I'm going to share with the notes, the proper notes, which will be written nicely for you guys. The full code from this I'm going to show. I'll also post the links of the video. So don't worry about the formats, because I know my keyboard has got some issues. But don't worry. Okay. So let's play with a real data set. So I'm going to import a data set. I've used my library read. So this is my data set. It's about the release dates. That's what you're going to play with, the release dates of ARA packages. So you see that the data set has got 7 variables and 107 observations. We have got the major column. Then we also have got the minor column. Then you have got the page, the date time, the time, and the page. So this is the data set that we are going to be working with today, to just start to manipulate it so that you have a feel of working with dates and times in R. Okay. So with this data set, I'm going to look at the structure of the date. So it's very key to examine the structure of the date column. This is what I was talking about in the introduction, that you need to inspect to see if the variables have been stored as a date. So when you run this code, we see that it's actually stored as a date, which is good. Then after that, you can also use the library anytime with the one that I was talking about. But we're not going to use it on this particular time. I'm just showing you the library in time. So let's say you have got a vector of data.